Okay, today we're going to be working on a 2000 Dodge Durango with a 5.9 liter engine, and we are going to be diagnosing engine starting problems. And now, although this is a Dodge Durango, the steps that we're going to perform are pretty much the same for just about any kind of car. And the first thing we want to do is we want to listen to the engine and see what it does. We're going to do that next. Okay, so as you probably heard, we heard the clicking of the solenoid. So the starter didn't even was able to engage. And now we have our list of usual suspects, that being a battery, dead or nearly dead battery, our battery connections. We could have a bad battery connection, and which can lead to the same. It's hard to tell if you have a bad connection, whether it's just a bad connection or a battery that's too low to be able to start the car. So now we pretty much by now we eliminated the battery connection because we can tell it's pretty tight. And in fact, this car had some starting problems a few days ago, and we disconnected the battery, cleaned the connections, cleaned everything, and the problem was solved. So we're sort of off the bat, we can eliminate the battery connection because the battery connection is real good. And in fact, we put a, if you can, maybe you'll see here, we put a little spacer just to make it a little tighter connection. We cut a little mechanics trick, cut a piece of coat hanger, and since our connection is still fairly good condition, we put a small piece of coat hanger to get a tighter grip on the battery terminal. So we're pretty much now think it's not that our connection, the battery, the cables look solid. So we now have to eliminate. We want to use a process of elimination and to arrive at our problem. So if we eliminate the connection, then we have a weak battery. Now there's also underlying reasons why the battery it's in such a weak condition. But we'll take it one step at a time. And first thing we want to do, we'll take our voltmeter and we set it on the volt scale. So we'll set our negative terminal, connect our negative and our positive. And we see that we have, I don't know if you can see that, we have about 9 volts. And that is too low to actually crank the engine and get it started. So we have a low, confirm we have a low battery, so it's not our connection. Our connections are fine. Our battery voltage is actually too low. So now, why did the battery get that low? And before we do anything else, we may want to find that out. And next thing we will want to do is find out if we can, by jump starting this car, we can get it to start. And if it starts, then we know it's the battery that's too weak to start it. Then that means the starter is fine, and so we'll do that next. We'll try to jump start it and see if it will start. And then after that, we'll diagnose why the battery got in such a weakened condition. Okay, so we're going to be connecting our battery charger, which has a starting mode engine starting mode. Do that, and we connect. So we connect our positive to our positive terminal, and it's usually safer to connect the negative to a good ground on the engine. So you need to pick a good ground on the engine and make sure it's not going to interfere with engine with the rotation of the fan or engine operation of the engine. So you want to put it somewhere and that you make sure you get a solid ground. It's contacting the engine or the frame or both. And so this is our charger, and the charger, we've had this for a number of years, and set it to the wet, and we Mickey Moused a little fan on the side because we found out the internal fan gave up, and we want to make sure that we don't blow the rest of the electronics by overheating the charger. So we Mickey Moused a little fan on the side there to get it to cool off the charger. So we're gonna get it to we're gonna give it a little boost first, and then we'll set it to engine starting mode. And we'll see what we get. And as you can see, this is a Black & Decker. We've had very nice charger. We've had it for a number of years, and it has an engine starting mode. And when once you set it to the engine starting, it provides 110 amps for just a few seconds, and it has a countdown. So once that countdown gets to 0, then we'll try starting the engine. Okay, so as we could tell, the engine had no problem starting. So that eliminated the starter. So the starter is in good condition, and eliminated the connection problem with the battery as well. So now that pretty much leaves the battery, and now the battery condition. We want to find out why the battery got in such a low state of charge that it would not start the engine. And in this case, the usual suspect would be the alternator, because normally in something like this, with starting problem, the usual suspects are the battery connections, and that many times can be the case, and that can lead to a weak battery. If you have a bad connection, the alternator may be in perfect shape, but it won't. The charge will not reach the battery because of a bad connection. So first thing we need to do is find out if the battery connection is good, and if not, we'll clean it and make sure that clean all the terminals and the battery posts and the battery cables, and make sure that we have a good clean connection, and then we can go from there and find out what the problem. The next step would be the starter, and find out if the starter is good. Like in this case, we know it's good. Then we continue. Now you could have the wires, the battery cables. They could be where they usually fail at the battery, but you can also have a problem with the ground from the negative cable at the usually at the engine, where it bolts to the engine or the frame, and you could have a bad cable on that end of the cable as well, a bad connection, I should say, at that end of the cable, which is also, it's unusual. Most of your bad connection problems will be located at the battery or near the battery. So now we need to find out, is our alternator generating enough amperage and voltage to charge the battery back up every time we start it. Otherwise, our battery will become weak every time we start it, because there's no juice going back in the battery, just going out. And then after a few times that we started, depending on how strong of a battery we have, one of the times that we go to start it, it will fail like it did now, because the battery will continue to get weak if it doesn't get enough charge until it fails. So now we're going to find out if our alternator is charging, it's putting out enough charge to actually charge our battery. And the way we do that, the first thing we want to do is we want to disconnect our negative battery terminal, and we use a 10 millimeter socket. We're going to be using a short extension with a small ratchet. We'll disconnect our negative battery terminal. Normally, this is the first thing you want to check. You want to check to see how good your connections are to the battery before you would go anywhere else. And in this case, we were pretty sure that our connections were good, since we had already a few days ago we had an issue with the battery connection. So, and that was corrected, and it was fine. Now it's exhibiting some problems again. It could have been as simple as a light left on, and then the battery got weak enough, left on during the night, and then the battery got weak enough that it won't start in the morning. So we'll have to find that out. Well, we'll check the alternator just in case to make sure. And then once we got that, we're going to, and this is important, we need to disconnect the negative battery terminal before we perform the following step, which is we're going to disconnect our hot terminal that of the alternator that actually comes from the battery. And this is a positive connection, so we want to also always disconnect the battery first, the negative battery terminal, to make sure we don't make a short circuit to ground somewhere in the engine, or could be the fuel rail, could be something serious that we don't want to be creating any short circuits, any sparks here. So we disconnect the negative battery terminal. Now we'll disconnect the hot terminal connection to the alternator, the back of the alternator, and the position here would be in a different engine, would be slightly different, but it's basically the same for most cars. The location may differ slightly. So you take the nut off, and that we use a 10 millimeter socket just like with the battery, and we just lip off the wire. There's a stud right there. This is the wire. Okay, and then we'll connect our voltmeter. We'll set it to the amps scale. We'll connect our voltmeter on the amp probe. We'll connect it to the terminal that we you can see that we disconnected from the alternator to the hot wire. This wire goes to the battery. It connects to the battery so the alternator can charge the battery. So we'll get that tight. That's my socket. Wonderful. Okay, so we were lucky enough to find our socket. Sometimes they just go somewhere where sockets, I think a place in heaven with where our sockets, all lost sockets and socks go, and yeah, you never find them. Sometimes it's a favorite socket, and yeah. There we go. Oh, I'm lucky again. Hit the floor. Okay, twice in a row, dropped the socket and retrieved it. That's amazing. So I think we're better not push our luck anymore today. Okay, so now that we got this connection tight, and then we'll connect our the other side to our the alternator terminal there. And then we'll need to get the car started, and then we'll make our measurement. So we'll put our battery connection back on. Then we'll set it to the engine starting mode. Let it give it a little juice. Once it settles, okay, we'll start our countdown. And with this charger, got a nice neat engine start mode. It'll count down, give you a countdown when it's ready to start the engine. And it counts down from it starts like at 999 up to 111. Once it reaches 0, then you can start the engine. Okay, so as we can see here, our alternator is putting out, on the amp scale here, is putting out almost 30 amps. So at idle. So that seems about right. Okay, so by performing this test, we also eliminated the alternator. The alternator is charging, so we have a weak battery that could have been the result of leaving some lights on at night, and or even the headlights or parking lights. And in the morning, by the time morning comes, the battery will be too low to be able to start the engine. So we'll need to actually find out if the battery has enough capacity to hold the charge, enough charge to start the engine. And as we eliminated the starter, we eliminated the connection and cable problems, and we also eliminated the alternator. So the alternator is charging the battery, so we know that battery should stay charged while the engine is running and the car is operating. So we'll have to evaluate the condition of the battery, if it has enough capacity to retain the charge. And usually the easiest way to evaluate the condition of the battery is to charge the battery, give it a good charge, and usually a good slow charge, and then find out what if it will retain that charge. Okay, and now next, before we charge our battery, we want to connect our alternator back. But as we did before we do that, we want to make sure we disconnect our negative battery terminal one more time before we move before we attempt to connect our alternator again. This is an important step that we need to take each time, and I know we're going back and forth, but it's necessary to perform this step because we want to eliminate the chance of creating a short circuit when we reconnect our alternator, because that alternator connection it's a hot connection that's going straight to the battery. So battery needs to be disconnected first, and we need to always disconnect the negative battery terminal. That way we also eliminate the risk of fooling around, disconnecting the battery terminal and grounding the tools, your tool, all your wrench on the engine or the frame. In this way, when you disconnect the negative battery terminal, if you hit the frame, there's no problem because it's negative to negative. There's no circuit that's being that is being completed. And once we do that, we'll proceed to connect our positive terminal to the alternator. So we'll disconnect our meter, reconnect our alternator. And we want to make sure not to drop this nut to the engine, because sometimes nuts, bolts, and tools that you drop into an engine, they're not always recoverable. And we're going to get that connection nice and tight. And it's also important, if your car has a cover, which sometimes, a lot of times they do, they cover that connection. Make sure you put the cover back on. This one actually has a insulator around it with a place to actually put in your socket with no extra cover, which actually serves the same purpose. But if you do have a cover, that usually a rubber or plastic cover that goes over the stud in the nut, make sure you put that back on. And now we'll reconnect our negative battery terminal. And we'll proceed, once we do this, we'll proceed to charge our battery. Make sure we give it a good slow charge. And we'll try to find out if some of the lights were left on, or is it that this battery just got to its end of its life. So now we got our battery connected. Make sure it's nice and tight. We'll charge the batteries. Okay, so we charged our battery overnight, and now we're ready to make one more voltage reading. And the reason we take a voltage reading is because a voltmeter provides a window into the battery condition by telling us the voltage. We get a picture of what's happening inside the battery. Each 12-volt battery is made up of 6 cells, each cell providing a little over 2 volts of electricity. And each cell is connected in series to the other cell, thus adding the voltage of each cell, hence a battery of cells. So you have a little over 2 volts per cell. There's 3 here and 3 here, so you got 2 times 6, so it's a little over 2 volts each cell. So A 12-volt battery should provide around 12.5 volts of electricity. This battery, it's putting out only 10.27 volts. So what that means is we have a cell that is either shorted or what is called an open cell. Either a shorted cell or open cell, which means there's one cell that's pretty much dead. So we are getting only 5 of the cells putting out electricity. Hence we get 10.27 volts. And that will not be enough to crank and start the car. So we'll be replacing this battery with a new one.
And I think that'll be it for this video. Thanks for watching. Hopefully this video was helpful. And please don't forget to subscribe and like and share. And as always, try to stay clean. Just try.